Today's lesson is on vectors, so go ahead and title your composition book Vectors. And we've talked a little bit about vectors, but vectors are going to talk about magnitude and direction. And magnitude is basically just the distance. So in this example, it says finding the magnitude of a vector, and a vector is just from one point to another. And so points P and Q are the initial, so P is the initial, and terminal points, Q, terminal, of the vector PQ. It said to draw PQ, I just included the image. So all I did was, is in a coordinate plane, write the component form of the vector and find its magnitude. So I plotted 0, 2 right here, and then 5, 4 here. So we have those two. And now what we're going to do is we're going to find the component form. So go ahead and just put component form. And all that is subtracting your x's and your y's. So it's going to look something like this. And we looked at it before. x2 minus x1, comma, y2 minus y1. So in our case, we have our x2, which is 5, minus our x1, which is 0, and our y2, 4, minus our y1, 2. So our component form of this vector is going to be 5, 2. So that's the answer to the component form. Now we want to find its magnitude. And when you find the magnitude, you're finding the distance. You're doing the distance formula. So if you recall the distance formula of a line, so in this case we have PQ vector, and the way you write a vector is you do a line and a little arrow, but don't do the bottom part of the arrow. And remember, distance formula, you're going to have your x's, you're going to subtract your x's, square it, and you're going to add that to your y's subtracted squared. So for this one, I'm going to look at my 2 points up here, go back to my initial points, and I need x2 minus x1, so that's going to be 5 minus 0 squared, plus my y's, which is going to be 4 minus 2 squared. And I'm going to get 5 squared, which is 25, plus 2 squared, which is 4, which gives me the square root of 29, which is approximately 5.4. So when we do the magnitude, yes, you do need to find the approximate value. So here's my component form, and here's my magnitude. So remember, magnitude, you use the distance formula. Component form, you're just subtracting your x and y values. Let's look at a different example. So we looked at the component, we looked at the distance formula, which is the magnitude. Now we're going to talk about the direction of a vector. So a direction of a vector is determined by the angle. So right now it doesn't look like there's an angle with the vectors, but what we're going to do is we'll make them into right triangles, and then we can use the tangent, we can use the sine or the cosine to find the angle, which gives me the direction of the vector. In real life applications, the direction angle is described relative to the directions north, east, south, and west. So if you were on a ship and you were trying to find that, because they use vectors, you would talk about north, east, south, and west. In a coordinate plane, the x-axis represents an east-west line. So down here on my x-axis, I have my east and my west, and then I have my north and my south. The y-axis represents that north-south line. Okay, so let's look at a real-life example. The vector AB describes the velocity of a moving ship. So it's saying where it's going and how fast. The scale on each axis is in miles per hour. So what we'll do here is, for A, it says find the speed. When you're finding speed, really that's just your magnitude. So we would use that distance formula. So let's look at our points. So point A is going to be over 5, up 5. So I'm going to write that right there so I have it. 5, 5, because it looks like they're going by 5s. So if they're going by 5s, let's find b. So 5, 10, 15, 20, 25. And it's up 5, 10, 15, 20. And that's my b. So here's my initial point, and here is my terminal point. So now we can use these points to find the magnitude. So I say the vector of AB is equal to the square root of 25 minus 5 squared plus 20 minus 5 squared. And that would give me 20 squared plus 15 squared. And that's going to give me the square root of 625 when I simplify it. And when I further simplify it by doing the square root, it'll give me a magnitude of 25. And it's miles per hour. So 25 miles per hour. Now let's look at it. It says find the direction it is traveling relative to the east. So what we're going to have to do here is we're going to go up here and we're going to make this a right triangle. Whoops. So I make it a right triangle, and I need to find what are the distances of these lines. So I have 5, 10, 15. So I have a 15 here, and I have 5, 10, 15, 20. I have a 20 there. And so I want to look at this angle here to find out the direction it's traveling relative to the east. And so I can use tangent. So if you look at tangent, remember that tangent is going to be opposite over adjacent. And so that's going to give me 15 over 20, which gives me 0.75. But that's not giving me the angle, that's giving me the tangent. And so what I need to do is plug that into my calculator, and I'm going to put the 0.75. And remember, I either put INV or second, depending on what your calculator is, and then put tangent. And so what you'll get there is approximately 36.9 degrees. So that is going to be your direction. So it's traveling 25 miles per hour at 36.9 degrees. Let's look at our last example. So let's say we're adding two vectors up. So when you add them up, the sum of u is just a and b, and the sum of u and v, they're telling me it's a1 and ab, or a1 b1 and v is a2 b2, is, so all you do is add those vectors. So you're just adding your x values and your y values. So let's look at this. We have u is 3, 5, and v is -6, -1. To find the sum of vector u and v, add the horizontal components and add the vertical components. So all you're doing is doing this. So u plus v equals, so I'm going to add 3 plus -6, and I'm going to add 5 plus -1. So I'm going to get there -3 and a 4. So that's what happens when I add my vectors together. And that's it for tonight. We'll deal with this tomorrow. Have a good night.